So, anybody want this question? No? We're good on this one?
Can you just go over the measurement again of the quadratic function?
Yeah, okay. So, well, first, think about what it looks like, right? Does this function open up or down?
Down.
Why?
Negative.
Because this x squared is negative. Yeah, the a term is negative. So that means it opens down. So does it have a top or bottom?
Top.
Top. So that means it has a maximum. Right? And then they want to know what is the maximum or minimum value. Remember, value means the y, right? So that means you have to find the vertex and find the y value of the vertex, right? How do we do that? What's the x value? What's the formula?
Negative b over 2a.
Negative b over 2a. So we find negative b over 2a, and then we plug it into the original function. Always go back to that original function if you want a y value. Okay? Do you want to do that out for this question fully, or does anyone want to see it? No? Yes? Yeah? Okay. So, let's see if I can get this to work today. So, if we want the x value, we just said that that would be negative b over 2a. So you always have to start there because that's where our formula is. So what would we have? What's the b value?
Negative 6.
Negative 6. Remember to always pull in that sign. So it's minus negative 6 over 2 times negative 1. Yeah. So simplify that. Negative 6 is just 6 over negative 2. So then 6 divided by negative 2 is negative 3. So from there, we just want to plug in, right? So we would have f of negative 3 is equal to negative 3 squared. So only that negative 3 squared, not that outside front negative, right? Okay, because that will change things completely otherwise. Minus 6 times negative 3 plus 4. Okay, so then we simplify. What do we get for the first term?
Negative 9.
Negative 9, because negative 3 times negative 3 is positive, and then we have that front negative. And then second term?
Plus 18.
Plus 18, plus 4.
18.
Oops, I don't know where 16 came from. I literally just decided to write a 6 when I said 8. That happens sometimes.
It does.
Yeah. Okay. So, negative 9 plus 18 is 9. Plus 4
13.
is 13. So, what's the, we said it was a maximum value, right? So what's the maximum value?
13.
13. Yep. It is just the y value. Okay? Alright. So, then, this is pretty much the same thing, right? Except we don't have a c value, but, well, that's fine, right? It doesn't really change anything, because to calculate the vertex, we really only use a and b anyway, right? Okay. And then what about these? Did these kind of give a little headache on trying to figure out which graph is correct? A little bit? Okay. Let's do this one, maybe? Okay. So, let's think about some features that it has, right? Does it go up or down?
Down.
Down. Okay? So, it can only be A or B. Right? Has to be one of those two. So already you've narrowed it from a 25% chance of getting it right to 50% chance. Halfway better already, right there. Now let's do this the simple calculation of figuring out whether the vertex should be positive or negative, right? Because if we look here, this vertex has a positive x value, right? While this vertex has a negative x value, right? So if we can figure out if it's positive or negative, we know which of these two graphs it is, okay? So look at those little differences like that between the graphs, and then figure out how to figure out, well, I shouldn't say it that way, decide how you should figure out which one it is, okay? All right, so we just want to find the x value of the vertex. So we know that that's negative b over 2a, which is, what's the top?
6.
Minus 6.
Minus.
Yep. Over 2 times
Negative 1/5.
negative 1/5. Okay, this is also a good one to do because of that. So, when we look at this, the top is easy, that's just negative 6, right? But the bottom, think about that 2 as 2 over 1, okay? And then, just to simplify things, multiply that bottom fraction of 2 over 1 times negative 1/5, multiply those together so that you just have one thing in the overall denominator, okay? And if it helps, write a really big denominator, like fraction sign, before you write your bottom fraction, okay? Because it is important to remember where that break is, okay? So then we have 2 over 1 times negative 1/5. What do we get? Negative 2/5. So, what do we do when we divide by a fraction? Multiply by the reciprocal. Okay, so that means we have negative 6 times what? Negative 5 over 2. Now, let's not just multiply that, right? Let's simplify. Because that 2 goes into the 6, leaving you with 3. Negative 3, yes, don't lose that negative. Either negative. So we have 2 negatives, so that means our answer is going to be positive, right? And then we have a 3 and a 5, so we get 15. Positive 15. Right? So that part's the important part, because now we know that it's on the positive side, so that means it has to be A. Right? You can also then choose, another point on the graph, plug in that x value, see if you get what you think you should get based on this graph, right? That's a really good way of checking to make sure that you chose the right thing. Don't obviously pick 15 because, well, we just calculated that kind of thing, right? Pick something else. Okay? And pick something that's different again from the other option. Okay? Alright, so were there any others in this section? No? Other ones are okay? Or at least repetitive of what we've already done, more or less? Yeah? Okay. Was there anything? Was there anything on the practice test? Yes or no, basically? Yes? Okay, so where is it? Oh, there it is. I passed it completely. Were there specific questions that were unfriendly looking so far, or not really?
You just do that for the heck of it.
Do it. Oh, this question. Oh, okay. Yes, sure, of course. So, how do we find intercepts?
X make y equals 0. Y make x
We
equals
make
0.
the opposite variable 0. So, for the x-intercept, we make y 0, right? So, if we're doing the x-intercept, y is 0. So that means we set the equation equal to 0, right? So we have x squared minus x minus 20 is equal to 0. Does that factor? What would happen if it didn't factor? There would be no x-intercepts. Yeah, I mean, try the quadratic formula, probably, would be a good decision, right? Because that could give you an actual value, even if it's not factorable, possibly. But this one is factorable, right? Question?
Yeah. So, when you're not, like, it's like a decimal form where you use the quadratic, so it's only when you have an I, there will be no intercepts?
Yes. Because, and basically that's saying it's an imaginary root, which means it doesn't really touch the x-axis. So we imagine it does, more or less. Okay? So we don't deal with those, really. Okay? So, how does this factor?
4 and 5.
4 and 5. So we have x and 4 and x and 5. What signs?
Minus 5.
Minus 5 plus 4. So that means x equals negative 4 and positive 5. And those are your x-intercepts. Remember, because it's x equals, don't put them as points. Just put the values. Okay? Don't put them in parentheses or anything either. Okay, so then we want to find the y-intercept. That means x is 0, right? Okay, so then just plug it in, right? So f of 0 is equal to 0 squared minus 0 minus 20. Well, that's just minus 20. We really, really like finding the y-intercept usually. It's always the easy one. That's why I always do it last, because it's like really quickly after I get frustrated by having to do all the work to find the x-intercepts, right? I'm just done. Okay, so again, that's it, right? Just put the value. All right. So I'll just flip through. Just stop me if you see something you want me to do. I have a question on this one for everyone. Is the blue line part of the domain of range?
No.
Why not? It's the asymptote. It's the restriction on the function, right? So that's telling you where the function will go to, but it's not actually part of the graph. Okay. Increasing, decreasing, constant, min, max. Do what?
No,
Oh, okay. I can't tell. You're just looking at me and I'm like, is eye contact mean you want me to do it or not? I'm not sure. Okay. Again, same thing. So you're just restricting the domain of the function. So as long as you know what your parent graphs look like, then these shouldn't be too bad. Because this is what function?
Oh, wait.
I have to face the same way as you, otherwise I do it backwards.
Oh, that's the egg.
No.
Oh.
I don't know.
Straight line.
Oh, that's what.
Straight
Oh,
line,
I thought it was.
Yeah, pretend my arm's connected, okay?
Right.
Yeah, just x equals. What about this one?
X squared.
X squared. What about this one?
Okay, X cubed.
X cubed. What about this one?
Yeah.
This arm's not there.
Oh, cube root of
Square root.
Square. Yeah.
What about, wait, hold on. That.
Okay, now that.
That's the cube root. What about this?
absolute value.
Absolute value. What about the one that I can't do with my arms? This scoops on both sides.
1 over x.
1 over x, reciprocal
Right,
function.
yeah.
Yeah, I can't. I'm not disjointed kind of thing. I can't do that. Okay, so as long as you know those, right, that will really help. Good on this. What about this one? These can be a little rough.
Yeah.
Do it? Okay. So, what parent graphs do we have? What does this one look like?
Absolute value.
Absolute value. I completely agree. What about this one?
A line.
A line that has positive or negative slope?
Negative.
Negative, because it's going down. Okay, so then if this is going down, and so that's basically like negative x, but with a different maybe slope or y-intercept, right? We'll have to figure that out, but we know at least what its base is. So then now we have to figure out which of these options we have, right? So what section of the graph is this on? Is the absolute value on? Domain-wise. Negative infinity to 2. Inclusive or not? Not inclusive, because it's an open circle for the absolute value portion. So that means it's when x is less than 2, right? What about the line portion? What does that look like? Domain-wise. 2 to 7. Inclusive on both parts. So we want something that is less than for one part, and then less than or equal to, less than or equal to. Right? So yeah, it looks like B is our choice. Okay, so that means we already know what these values should be with the inequalities, right? It's just the domain pieces that we just said. So for the first one, x was less than 2. For the second one, x was greater than or equal to 2, and then it went to 7. Yeah. It's the x value. Because it's inclusive, we just go to the point. We don't go past.
I have the answer on mine. Like, your B is my A. That's so weird.
They switch them around. They're not consistent
Okay.
on where they put them. Yeah. I don't know. Okay, so then, does this look like a basic absolute value function?
Yes.
Yeah, right? It still goes through 2, 2. It goes through negative 5, 5, and everything, right? So this is just absolute value of x. What about this one then? How do we figure out what that line is? Find the slope. Yeah. Okay, so let's do that. How do we do that? Use the 2 points. So we have 2, 0, and 7, negative 5. So, what do we have?
Negative 5 minus 0.
Negative 5 minus 0 over
7 minus 2.
7 minus 2. So we have to stay consistent. And which point we put first. So we simplify and we get what?
Negative 5 over 5.
Negative 5 over 5, which is
Negative 1.
negative 1. So we already know that it's, oops, I forgot that I was in pin mark mode. Okay, so we already know it's just negative x, but we don't know the y-intercept, right? How do we figure that out?
Point slope.
Point slope, yep. So, you could look at the graph and kind of extend it to see where it should hit the y-axis, but the kind of foolproof way is just to plug into point slope and solve. So what point do we want to use?
The
Pick
positive.
the easy one, right, the 2, 0. Always choose the one with 0 in it, if you can. So, what is our equation?
Y minus 0.
Y minus 0 is equal to
Negative 1.
negative 1 times
X minus 2.
x minus 2. Well, minus 0 just goes away, right? So this is just negative x plus 2. That's our line. So we're just right here at plus 2. So you can check it, right? Pick another kind of random point on any of them. Pick an x value, right? And say, okay, well, I would plug, let's do negative 5, right? I would plug negative 5 into this portion because that fits into that part of the graph domain, right? And then, well, the absolute value of negative 5 is 5. Oh, that gives me that point, right? So there's, and then check something on the other piece, and, okay? Any questions on that one? Okay. So this is plugging in points essentially, and then choosing the correct graph.
Can you do that one?
Sure. So, how do we choose where it goes, right? If we want f of 1, which one do we plug it into? Which part?
First,
The first one, because 1 is less than or equal to 1, right? So, we plug it in to 3 times 1 minus 3, and we get
0.
0. Yep. So, that's the first answer. Then, what about the second piece? Where we're plugging in negative 1.
Second one.
The first one.
First one again, right? Because negative 1 is less than or equal to 1. So, 3 times negative 1, negative 3,
3.
minus 3,
Negative 6.
negative 6. Yep. What about this third one? Where x equals 2.
The second one.
That's the second one because 2 is greater than 1. So then 2 plus 2 is
4.
4, and that's it again. So, let's see, we had points, oh, I'm running out of time. Okay. We had points 1, 0, negative 1, negative 6, and 2, 4, right? So if we know points already, that can help us pick the graph. Also, look at the inequalities and see what kind of closures they should have, right? So what you want to look at is this portion right here, okay? And knowing that both of these lines have a what type of slope?
Positive.
Positive. So the lines should both be going up, right? That means it can only be which choices?
A and C.
A and B, right?
With the different, seriously, I have a different version of what you guys are. So weird.
They just completely switch them up and stuff. It's just a pool of questions. So A and B are both positive slope, right? So again, 50% chance of getting it right already. Then, if we look here at this portion of it, right, we see that x is less than or equal to 1. That means the first part should end in a closed or open circle. Closed. Then, x is greater than 1 means the second part should start with a open circle. So it has to be B. Okay? Then, check to make sure these 3 points fall on this graph. Okay? But that should do it. Did that help? Okay. Are we good on this one?
Just if it's with the X, you just switch it, right?
Yep. It's always going to be the opposite if it's with its X, essentially. Okay. Are we good here?
That's the same thing. We just write the equation.
You're going backwards on that one, yeah. Tomorrow. Okay. We good on this one? Which do we do first? The reflection or the shift?
Reflection.
Reflection. So because you start at the X and work your way out, essentially. Okay? So if anything was inside of with the X in the squared portion, you would do that first. So shift left or right, then reflect and stretch, compress, then move up or down. Okay? What about this one? We good?
Is that a vertical shift?
Okay.
That's a vertical shift.
No.
Compression.
What is the thing?
Vertical.
If it's greater than one, the coefficient greater than one?
It stretches.
Oh, not shift.
So-
I meant stretch with the S.
Yes.
Yeah.
Yeah. So just remember that it's always along the y-axis. You want to tell them?
It's on the y-axis as opposed to the x-axis. So
Yes.
it's going up and down instead of
Because
left and right.
it's outside of the X area, right? You got it.
Yeah.
So if it's bigger than 1, you're stretching, right? If it's less than 1, you're compressing. Okay, so always it's an up or down thing. Okay. So we're good on all of these? Just function algebra, basically. Now function composition. Just remember on these, you have to fully simplify, which means one fraction factored, if it can be, okay? Otherwise it will mark it wrong.
And that's F of G?
F of G, yes. So we're plugging G into F. Hmm? What about this one? This one shouldn't take too long.
How do you, do that? Like, how do you find
We switch the points, right? So if this original function graph has -4, 3 on it, then our inverse function graph has
-4.
3, -4 on it. And then the same thing with -3, 4, then it has 4, -3. Instead of 0, 5, it has 5, 0. So instead of here, it would be here, right? So that means it is B. See how, right? If we kind of remember what it looked like, it was like this, kind of. They're just mirror images of each other around the y equals x line. Okay? This one. We good on this? We did quite a few of these on Thursday. So we're good? Not good? You want me to do it?
I have a question.
Yeah.
For the inverse, it's like whatever y is, it's x.
Yes.
So
They just flip.
0
So if you want to know f inverse of 0 equals what, that's f of what equals 0.
So x is 0, so what's y?
Flip it.
The opposite, right?
Y is 0, so what's x?
Yes. Yes. So think about it the opposite way when you're looking at the inverse, right? Change it to say it about x. Does that make sense what I just said?
Yeah.
Okay, so I have to make sure because it makes sense in my head before I say it, but it doesn't always come out right. Does it make sense? So. We're good on this? This one? Before that?
No, this one.
Wait,
No, is it, what is that one? I'm sorry. It actually wasn't before this stuff.
I don't know which one you're saying is the one before that, because I'm going back and forth now too many times. What did it look like? The one we were talking about before?
Question I
The one you were talking about before, yeah. This one. Yes. Do you want to go through it fully, or, yeah?
Like, can we run through it, or go through it at the same time?
Sure, okay. So domain of f inverse, what do we look at for that? The range of f. So this is f, so what's its range? This is 1, 2, 3, 4. This is 4, negative 4, to positive 4. Inclusive, right? So if that's the range of f, that's the domain of f inverse. Then the range of f inverse is the domain of f. So what's the domain? Negative 5 to positive 4, right? Inclusive again. Both of these are inclusive because the endpoints are full, right? Okay, and then what is the y-intercept of f inverse? It's the what of f? X-intercept. So whatever it is, just flip x and y, right? For inverses. Okay, so then we want to find f inverse of 0. That means we're finding f of what equals 0. So what x value gave us 0 on this graph? This point, right? Whatever it is. Negative 3. Okay, so that means f of negative 3 equals 0, or f inverse of 0 equals negative 3. What about this one? F inverse of 3 equals what? So that means f of what equals 3? Well, 3, wait, f of what equals
So y is
3, right?
X is 0.
So 0, yes. See, I can even confuse myself sometimes. Okay? Did that help? Okay. Put on these. Yeah? Previous? I did one like this last class, and I did one like this when we did the section as well.
So the bottom equals 0?
Yeah.
For the domain of f and the range of f inverse, yes. I'm just making connections all over the place. Okay? And then we just spent a whole bunch of time kind of talking about this stuff just a minute ago. Right? Are we good? And I'll ace the test tomorrow?
I have a question. The axis of symmetry is the y.
The x. X equals the x value. start 4.2 really quick for just a little bit. So 4.2 is applications of quadratic formulas. Turn on this light. Now that we're not projecting anymore.
What book are you went to for your regular primary book?
So we'll go through at least this first problem. So we have applications of quadratic functions. So it's literally just applications of 4.1. Okay, that's why it's 4.2. All right, so it's a word problem that we're going to start off with. We threw a ball, so we're very active, in the air. The height of the ball, h in feet, after t seconds, was given by h of t is equal to negative 12 t squared plus 21t plus 6. Okay, so first what we want to do is how long does it take for the ball to reach its maximum height? What is maximum height? It's the vertex. Yeah, it's the value of the vertex, right? Because height is the y. So, where do we have to start? Finding the x value of the vertex, which really in this case is the t value. So t is equal to negative b over 2a, which is what in this case?
Negative 21.
Negative 21 over
2 times negative 12.
2 times negative 12, which is
Negative
negative 21 over
negative 24.
negative 24, which we can simplify. 21 and 24 both have a
3.
3, and they're both negative, so that means positive. So if we take a 3 out of both, we get 7/8, which possibly they would want it in decimals for once in this whole entire class so far. It would be 0.875 seconds. Okay? Just put it in the calculator. Okay? Then, what about, are we done actually?
No.
Why not?
The x with the
That's just the x value. We have to find the y value now, right? We have to plug this in. So, we have to find h of 7/8 or 0.875 seconds. So that is negative 12 times 0.875 squared plus 21 times 0.875 plus 6. Anybody bring their calculator to class?
yeah, but somebody's gonna do it for me.
Get you active. What's the first term?
Negative 9.1875.
negative 9.1875. Is that what you said?
Yeah.
Do we agree? Yes? So then what's the second term? 21 times 0.875. 18.375 plus 6. So then what do we get? If we add those together. 15 point what?
1875.
I agree. In feet, right? Because it is important to remember units when we have them. Okay? That is our answer because, oh, actually, I'm sorry, I went too fast. They just want to know how long. It means we should read the question a little bit more careful, right?
So how long?
They just wanted this. How long? Most likely, yeah. We overachieved. That's okay.
So
We just got a 3-pointer instead of a 2-pointer. It's all good.
So 15 is the height.
15.1875 is the
actual
height. That is how long it took to get to the height.
Okay.
So, now for B, we want to know what is the height. Well, we already did it, right? So this was, B was, what is the maximum height of the ball? And then we could ask, right, how long until the ball reaches the ground? What does that mean? Does t equal 0? I'm sorry? How long until the ball reaches the ground? What does it mean for the ball to reach the ground?
X-intercept.
The x-intercept, which is really meaning that the height is 0. It's at the ground, right? So ground is 0 height, right? So you're finding the t value. You will get 2, right? Because it's a quadratic. You're setting it equal to 0. One of them might be negative. Is that a valid answer? No, because it's seconds, right? It's time. Okay? We're not asking that in this problem, but a lot of times we are asked that in these types of problems, so that's why I went through it, kind of. Okay? Next, what we'll go through on Thursday is starting into business applications. Okay? So we'll start talking about revenue and cost and profit and price demand equations and all that fun stuff. Okay? So this is good for those of you that are business majors. If you're a science major, we will get into that in a future section. Okay? More so. So it's just the business part. Don't forget that 3.6 and 4.1 are due tonight. Okay? And I'll see everyone for the test tomorrow. Have a good night.
Good night.